Once again, title your paper, your notes, Arithmetic and Geometric Sequences. Arithmetic and Geometric Sequences. Can you read us the objective? Cesar, go. I couldn't hear, I'm sorry. Okay, here it goes again. I said title your paper, Arithmetic and Geometric Sequences. So can you read us the objective, please? Oh, sorry. No, the objective. Go. Everybody on three? 1, 2, 3. So today's concept is arithmetic and geometric sequences. Those go inside your Freire model. Arithmetic and geometric sequences. What are arithmetic and geometric sequences? They are a list of numbers, each number known as a term, that often form a pattern. Those patterns are known as the common difference or common ratio. Examples: 1, 5, 9, 13, 17, 21, and 1, 5, 5, 25, 125, and 625. Copy that, please. Okay, writing utensils down, look up, please. Let me go over this one really quick. Cesar, ready? I said pencils, writing utensils down. Yeah, here we go. Look up, please. It says, arithmetic and geometric sequences are a list of numbers. Do we have that? Yes. Also, it says, in those list of numbers, in those list of numbers, each number is known as a term. So look at this list right here. What is the fifth term? Listen. Yes. I said each number is known as a term. For this list right here, which is the fifth term? Thank you. How about the third term on this one, Shakira? 25. So we get the understanding of terms, right? All right, so with that said, look up to the screen, please. I'm going to start with, in red, and I'm going to start with arithmetic sequences. What are arithmetic sequences? They are sequences that either add or subtract constantly for the pattern. So watch. So what is the constant pattern then? Plus 4, and it's consistent all the way through, right? If it's consistent all the way through, then we call that a common difference. Common difference, bless you. And this number is known as the letter D for what? Common difference. Or they also use a lowercase d. There it is. Geometric sequences are sequences that either multiply or divide the pattern throughout consistently. So let's see. What's happening? Times 5. Is it consistent? Yes. If it is consistent, then this is known as a common ratio. The letter for common ratio would be what, everyone? R, or lowercase r. Copy that, please. Yes, I'm good. All right, here we go. Next, copy these non-examples. 1, 3, 6, 8, 16, 18, and 36. As you're copying that one, try and see if you can find a pattern. Don't say it out loud. Keep it to yourself. Talk it over with your neighbor and see if they found a pattern. No? All right, let's see. Pattern. Cesar. What? Tony, what's the pattern? Plus 2 times 2. Let's see if it works. Plus 2 times 2. Plus 2 times 2. That is correct. Now, talk it over with your neighbors. So I don't know why this one is not in either an arithmetic or a geometric sequence. Why is it not that? All right. Danae, why is this not a arithmetic or a geometric? I'm sorry? Which means, why is this not a... Melanie, help her out. Sebastian.
Because an arithmetic and geometric sequence only has one pattern, because in the definition it says equals a pattern, which means one, and in the non-example, it does 2 patterns.
Bam! Did everybody hear that?
No.
All right, good. He said that, and very specific, he said, in arithmetic and geometric sequences, arithmetic has only one pattern, which was just adding. A geometric sequence had only one pattern, which is multiplication. And this one is combining both. That's why this is a non-example. Bam! Sebastian. That is correct. So, with that said, we need about 3 hashtags. Let's see. 1, Daniel, go.
1, patterns.
Patterns. Thank you. Wyatt, another one. I don't think that would qualify. That was who can give me another pattern? Lorena, go.
I think he meant by add.
Oh, bam! Very good. Good save. Good save. Another one, Julianne, go. Hashtag.
Hashtag math.
Hashtag, that was a cop-out. Who give me one more? Sebastian. Hashtag multiplication. Anything else? Julian.
Hashtag yellow submarine.
Anyways, copy these next steps, please. Okay, so for today, we have 2 different sets of steps, so write them down side by side. And we're going to have steps for the explicit rule and steps for the recursive rule. And right now, you're probably asking yourself, what is one to the other? So you'll find out. Steps. For the explicit rule, write the explicit rule for the function, substitute the values of the term, and simplify. Recursive rule. Steps: identify the pattern, which is the difference or ratio. Step 2, define if the arithmetic or geometric sequence. Step 3, write the formula and substitute values. And step 4, simplify. So, by looking at these two sets of steps, which one will you presume to be easier than the other? Which one would be the easiest? Explicit, yes, because it requires less work. Is that correct? So then, I'm going to first show you how to do the explicit rule. From there, I'm going to show you how to do the recursive. We'll copy this for right now. I'm going to go ahead and show you the example first. Don't copy, just writing utensils down. I need you to pay full attention. Now, this is one of the those areas that are a little bit misunderstood. If you want to make it a little bit leave it on the positive note, but even in college, some people misunderstand these sections, which is the sequences. So, pay attention, please. Look up. Look at this example. Don't write it down, just pay attention. I'm going to start with the explicit rule. Look up, please, or you're going to miss it. Here it goes. Explicit rule. Example 1Q. Find the first 4 terms of the sequence defined by the function f of n equals n squared plus 1. Now, this is a little bit familiar, but not quite. And as I've been showing for the rest of the day, let me make it so that it's a little bit more familiar. And I show it like this. Does that look familiar? A little bit better, right? Because it's a 2-variable equation. Are we in 2-variable equations now? Yes. But instead of using this notation, today we're using a notation called function notation. That's why we have this right here that's called f of n. What is it called? F of n, which is function notation. And if it's function of n, then that means this variable has to be n. Are we there? So check this out. They're asking us to find the first 4 terms. So the very first thing I'm going to do, I'm going to make a table. But instead of writing x and y, which one was the x here? N. And which one was the y? F of n. So they want us to first find the first 4 terms. 1, 2, 3, 4. So check this out. I'm going to start with this first term. The first term is 1. So this becomes f of 1 equals 1 squared plus 1. Are we there so far? What is 1 squared? 1. So it is 1 plus 1. 2. All right, everybody knows how to do this. Look at this side, though. I want to clarify this side. What did you guys notice? Stayed the same. We don't do anything. The parentheses does not mean that we're multiplying. It just says that it's a function of 1. So we're using 1 throughout, and this is just showing what we're working with. So what is f of 1? 2. And that goes right here. Let me show you another one. The next one is what? F of what? F of 2, which is 2 squared plus 1. F of 2 is what? 4 plus 1. So f of 2 is 5, and that goes right there. Copy that and fill in the last 2, please. Let's see, Christian. What is f of 3? I'm saying, what is f of 3? F of 3 is what? Remember, this is an exponent. Look up, Christian. It's not times 3 times 2. This means 3 times 3. Therefore, what is f of 3? Ryan. 10. Hands if you got that. That is correct. Here goes. Let me show you that one. F of 3 is 3 squared plus 1. F of 3 is, what is 3 squared? 9 plus 1. What is f of 3? 10. All right. What is f of 4? Go ahead, Christian. $17. Hands if you got that. That is correct. Does everybody see how this explicit rule works, right?
Yeah.
Isn't it very similar to what we used to do? Like just filling in the table? All right, so therefore do this next one by yourself. Example 1, super cube. You don't have to write the instructions anymore. Just write the function. F of n equals 3n plus 1. And fill in your table with 4 terms. And I'll help you out with this one just to get started. There you go. Oh, wait, let me straighten this out. All right, ready, go. Copy that and finish it off. Let's see, help me set up the table, please. Go ahead, Marcelo. What goes on top? F of n. F of n, okay? How about here?
1, 2.
Thank you. Therefore, what is f of 1? Daniel. 4. Pass it to someone. Marcelo, was it f of 2? 7. Pass it to someone. Jen, what is f of 3? Okay, I'll come back to him. What is f of 3, Jen? Close. What is n now? 3. So if it goes in here, therefore this is 3 times 3 plus 1. 10. Yeah. What is f of 4? Go ahead, Jen. 13. Hands if you got that, please. All right? We got this, yes? All right. So, look at this one, though. They're going to give you something like this in tonight's home plate. Very similar to what we did. It's still explicit, but look how it's going to be written. They're going to say, find the 8th term of the sequence defined by the function when the domain is all whole numbers greater than 0. And here's the function that they give us. Well, let's go to the previous ones. How many terms did they ask us to find? Which is the 4th term? The 4, right? Therefore, here we go. Tell your neighbor what to write there. Roberto. 8. Why 8? Because they're only asking us to find the 8th term. Do they ask us to find the first 4 terms? No. Therefore, we use this one, f of 8 equals 2 times 8 squared plus 6. F of 8 equals 2 times, what is 8 squared? 64 plus 6. F of 8 is 2 times 64, that's 128 plus 6. F of 8 is 134, and that goes right there. Copy that, please, so you can have it as reference. Okay. Pretty simple. Show me with the fingers how comfortable you are with the explicit rule. Got some 5s, some 5s, some 5s, some 4s, some 3s, 5s. There is no such thing as negative 0. 4, yes. Okay. Omega. All right, here we go. So, writing utensils down. Now we're going to go to the funner one. Here we go. Look up, please. Recursive. Look up, please. Writing utensils down. Pay attention, please. So here we go. Example 2A. It says, using a different notation called recursive form. For recursive form, they're going to give you 2 formulas. One for the arithmetic sequence, and this is a formula given. F of n equals f of n minus 1 plus d. And geometric sequence, which is f of n equals f of n minus 1 times r. Now look at these 2. Tell your neighbor what is the only difference from this one to this one or this one to that one. Let's see, Danae, can you elaborate on that? Which is the difference from one to the other? Arithmetic is adding D, which is called the what? Bam, the common difference. And this one is doing what? Which is common ratio. Hands if you got that. Yes? That is correct. So the only difference from this one to this one, the first part is the same, but the last part changes because the arithmetic, they add, the geometric, they multiply, right? So, this is how this goes. Look up. They're going to give you a sequence such as this one. Look up, please. And don't say it out loud. Keep it to yourself. Once you see the sequence, you need to identify if it's in arithmetic or a geometric. Once you identify that, you need to identify what D is and which formula to use. I mean D or R, sorry. Here we go. So with that said, what was the pattern, everyone? They're adding 4, is that correct? Yeah. So therefore, if they're adding 4, this is what we call the common difference, yes? Okay. So if it's a common difference, which formula we're going to use? It's for the arithmetic sequence. Are we there? So now in order to find the next term, we need to label the terms. This is term number 1, 2, 3, 4, and which one are we looking for? 5. So this is what we're going to do. I'm going to take this term, substitute it in here, and what is D we said? 4. Okay. I'm going to keep going. F of 5 equals, look at this part. Look up. What is F of 5 minus 1? F of 4. So let me ask you this. What is F of 1? What is F of 2? What is F of 4? I bring this down, and I bring this down. Therefore, F of 5 is 25, and that goes right here. Let's see if it works. Plus 4, plus 4, plus 4, this is, yep, and that works. And that's how you do those. So what is the difference between the explicit and the recursive? Talk it over with your neighbors. What would be the only difference that you see from this one to this one? Talk it over, please. Let's see, help us elaborate on this one, Juliana. What is the difference from the explicit rule to the recursive rule? What do you mean by, what do you mean by harder? What does that mean? It has more steps. Does everybody identify that? The other one, just explicitly, you just substitute and compute. This one, you substitute, but you need to take a pause here, and you need to substitute one more time. Does everybody see that? Okay, did everybody copy this? Okay, copy that, please. And then I want you to copy the second formula, because we're going to do an example for that. Copy that, please. All right. So, for arithmetic sequence, it's a common difference, and that's what we got there. Thank you. So look at this next sequence. Why? What do you see? Okay, so he said multiplying by 4, therefore this is a letter what? R. And do you see how this is going to be working out the same way as we did the previous one? But instead at the end you just multiply times 4, is that correct? Okay, home plate for tonight is found on page 138, all. So tonight's home play is a little challenging, so I'm going to upload the video right now before the end of the day. However, there is also tutoring. Okay, glad to see you in tutoring. See you guys tomorrow. Bye.